Question number 9 from exercise 7.2 ML Aggarwal. It says that if x plus 5 is the mean proportion between x plus 2 and x plus 9, if between these two the mean proportion, so between these two the mean proportion should be the under root of this, but it's given that x plus 5 is actually the mean proportion between this and this. So if you remember, then if a to b was equal to b over c, and then b square is equal to ac, or b is equal to under root ac, b was said to be the mean proportion. This b was named as the mean proportion. If you remember from your learning, it was called mean proportion. So this b is a mean proportion which is numerically equal to the under root of the product of the extremes, that is a and c. So it says question clearly that x plus 5 is the mean proportion between x plus 2 and x plus 9. So what has to be done with this x plus 2 and x plus 9? We need to multiply them and do the under root of them, and that should be equal to the mean proportion. So this is actually given. It says if x plus 5 is the mean proportion between x plus 2 and x plus 9, find the value of x. You need to solve it for x. So quite obvious, to remove this under root you need to square both the sides. So if you square both the sides, you get x plus 2 into x plus 9 is equal to x plus 5 whole square. I hope you follow this.
Yes, sir.
So now your ability lies in opening this bracket. It becomes x square plus 2 plus 9 is 11x plus 9 to the 18. This is how you open. Otherwise, the way you know how to open, you can open the bracket, is equal to, you can see here, x square, a square plus b square plus 2ab. So x square plus 10x plus 25. Right? Bring all the terms on one side. X square minus x square plus 11x minus 10x plus 18 minus 25 is equal to 0, so that we can reach to some sort of solution. So you can see, though it appeared to us like it is going to be a quadratic equation, but because this x square gets cancelled with this x square, we reduce our trouble. That is 11x minus 10x is only x, and this 18 minus 25 is what? Minus 7 is equal to 0. So beautifully x comes out to be 7, your answer. Hope you understand this.
Yeah.
Question number 10 of exercise 7.2 of ML Aggarwal says that what number must be added to each of the numbers 16, so it becomes 16 plus x, 26, it becomes 26 plus x, and 40, so it becomes 40 plus x, so that they may result in continued proportion. So they may result into a continued proportion, meaning this upon this is equal to this upon this. See, numbers they gave was 16, 26 and 40, but they were in none of the proportions. Question says what must be added? तो हमने क्या दिया? Let x be added to them. So adding x to them makes them in continued proportion. Continued proportion meaning 16 will become 16 plus x, 26 will become 26 plus x, 40 plus x will become 40 plus x, and they are in continued proportion, meaning a over b is equal to b continued here over c. And now see, though this is a question given in continued proportion, that is ratio proportion, this becomes a question of quadratic equations. See, if you cross multiply, that is again a property of ratio proportion is applied here by alternando, that is by cross multiplying. Because right now you have not learned alternando, so I am saying by cross multiplying. Very soon I will be saying by alternando, and we'll keep on saying that forever. By cross multiplying, what do we get? We get 16 plus x into 40 plus x is equal to 26 plus x into 26 plus x. And this is quite big multiplication. And see, I'll teach you how, and you know also this how. I mean, I will teach you a bracket multiplication with bracket. No, at all, not at all. I mean, you know this very well. X square, it becomes x square plus, because both are pluses, 40 plus 16 is 56. X plus 40 into 16, 16 into 4 is 64, so 640. Check me if I am wrong anywhere. 16 into 4 is 64 and into 10 is 640. Hope you're getting my voice and my picture clear.
Yes, sir.
Okay. So this becomes x square. And now see, this is what? A plus b whole square. So a square plus b square is 26 ka square. So find 26 ka square for me in the meantime. Plus 26 plus 26 is 52x plus what? Calculated? No. 6 6 are 36, carry 3. 6 to the 12, 13, 14, 15. How can you be better than the master? So master is there doing before you. 6 6 are 36, 3, 6 to the 12, 13, 14, 15, 2 6 are 12, carry 1, 2 to the 4 and 5. See, still you are not able to do. So it's 676. So bring all the terms on one side. X square minus x square plus 56x minus 52x plus 640 minus 676 is equal to 0. Brought all the things on one side. So this becomes what? This becomes non-solving.
Non-quadratic equation.
This goes. So it ceases to be a quadratic equation. I have wondered that this should become a quadratic. It appeared like it's going to become a quadratic. It ceased to become a quadratic because x square and x square vanishes. So it becomes a linear equation, class 9. 56x minus 52x is 4x. Minus, you can see, 26 is equal to 0. So quite handful for you. 4x is equal to 26. Gives you x is equal
to 9.
26 upon 4. Mind you, not 36, it's 26.
Sir, 36. 36.
I'm so sorry. It's 36. It's 36. So 36 over 4, and you people prove that you are good mathematicians. That is, x is equal to 9, and this becomes your answer. Good. Thank you. You understood. When I picked this question number 11, this is an important question for examination. This comes in the examination. It says find two numbers such that the mean proportion between them is 28 and the third proportion to them is 224. So we need to find two numbers. So let us say, let those two numbers be x and y. You could have taken it as a and b as well. You could have taken it any two alphabets. Now these two numbers are the one between which the mean proportion
x upon 28 is equal to 28 upon y
is 28. Yes, you can say it that way, or you can also say that xy is equal to 18 square, if you think it in that manner. That is, x upon 28 is equal to 28 upon x upon y will give you 28 square is equal to xy, and this appears quite handy to me to write in one line. That is, let those two numbers be x and y, as 18 is mean proportion between them. Therefore, what can I say? I can say that xy is equal to 18 square. I hope you will buy this. It's okay with this.
So it's 28 square.
Sir, 28 is mean proportion.
Yes. Pardon me for this. I was just trying to, I want to find whether you are there or not. So 28 square. So you prove that you are there. It's not 18, it's 28 square. So now, next, what? These two numbers are the same one between whom the third proportion is 224. So that means x over y is equal to y over
upon 224.
This means the mean proportion, and this means the third proportion. This is all
is equal to 24 upon
rough
24
I am doing. Yes, and that means what? That means y square over x is equal to 224. This means what? Y square upon x is equal to 224, and you need to write a statement here. that is as 224 is third proportion between them. So I hope you will understand this. You're understanding this, I suppose, because mean proportion. So yes.
Sir, from the x y is equal to 28 square, we can write y is equal to 28 into 28 upon x. X is equal to 28 upon 28 into 28 upon y.
Meaning,
and in this equation we can substitute it.
Is this not clear to you?
Sir, this is, yes sir, this is clear.
This is also clear?
Yes sir.
Okay. So now you make this equation, because it was given that 224 is the third proportion between them. So third proportion means whenever things are in third proportion, then A over B is equal to B over C, and C is called the third proportion. So that third proportion was given 224 when A and B were the two numbers, and that are x and y. So x upon y is equal to y upon 24. From here I could make out this, that y square upon x is equal to 224 by alternando cross multiplying, that is. So I am only right now dealing into your understanding of these two equations. That is, because it was given that 28 is the mean proportion between them, therefore x into y is equal to 28 square, and because 224 is the mean proportion between them, therefore because of this understanding we can say y square upon x is equal to 224. Now solving may be many, I mean what you are saying is also correct, and what others can even think of is perfectly okay. I mean, see what idea is behind that. There are two equations and two variables, solve them eitherly to get x and y. So you can be intelligent enough to solve it, isn't it? You could simply multiply this xy with y square upon xy, because I could see x and x getting cancelled, isn't it? What do you say? Isn't it? This
Yes, sir.
x and x gets cancelled, and so I've got y cube is equal to, and I can factorize these to get cubes of something. So 28 can be 7 into 4 into 28 can be 7 into 4, and this 224 can be factorized. 224 can be factorized as 2 1 1 2 2
28 into 8.
Okay, 2 5, yeah,
Excuse me,
and this is,
So it will be the cube of 56.
okay, so that makes it 2 again into 28. So it is actually 2 into 2 into 2 into 28, and again 28 can be written as 7 into 4 into 7 into 4 into 2 into 2 into 2, and 28 again, this is all my rough work, and 28 again can be written as 7 into 4. So see, it took a while to factorize, but we able to factorize. And see, 7 cube, you can finally end up into 7 cube, into see 4 cube, and you see it is 2 cube, isn't it? Y cube. And we'll just check whether your answer is correct or not. See, y therefore taking cube root. So you need to mention here taking cube root. If you take cube root, meaning you remove this cube, and it's always good manners to write these statements, because in examination, no matter whatever board you belong to, you tend to lose marks when you don't write the statements. So you get y is equal to 7 into 4 into 2. Yes, 7 4 the 28 into 2, and you're perfectly correct when you say that. That is, you are saying that 56 is the answer. 56 is y actually. One of the answer is y.
X equal to 14.
Yes, and now I will use this rough space to write further for you the value of x. Now again, there are various ways by which you can find x, but I will concentrate on xy is equal to 28 square, and I can substitute the value of y equal to 56 here is equal to 28 into 28, and by my little mathematics I know your answer is correct. 28 into 28 over 56, and 28 ones are and twos are, it becomes 28 upon 2, and yes, x comes out to be 14. Perfectly correct. Still you are the winner. You have done it before me. So finally, need to write the answer. Finally, those two numbers were asked. So those two numbers are 14 and 56. Your answer. This statement means 1 mark. which can be
Sir, can I
compromised,
finish my working?
which can be compromised if you don't try it. I hope you understand that. Proof wala questions like question number 12, exercise 7.2. It says that B is the mean proportion between A and C. So very clearly B square is given as AC. So obviously, because B is a mean proportion between A and C, so if B is a mean proportion between A and C, I can always write B square is equal to AC. Did you follow this?
Yes, sir.
This is given. And we need to prove that with the help of this B square is equal to AC, I need to prove that A square plus B square and B square plus C square are proportional. Right? So if at all
Yes.
these four are proportional, that is, if at all these are proportional, then what is in our hand? That is, we need to prove what? We need to prove that A over C, that is first term over second term, must be equal to the third term, that is A square plus B square over B square plus C square. That is, if we need to prove that these are proportional, then if at all they are proportional, we need to prove that A over C, that is first term over the second term, is equal to the second term over the third term. So I hope this understanding of what to prove is coming in your mind.
Yes, sir.
So first we'll catch hold of RHS. Obviously LHS doesn't have any scope of solving in it. So I catch hold of RHS. See, prove, when a question of proof comes, you cannot go ahead with both the sides. You have to catch hold of one side and try to reach to the second side. Actually, we should start from LHS and go to the RHS, but at time we have to also catch hold of RHS and go to the LHS. So RHS is equal to A square plus B square
Plus AC.
over B square plus C square. You want to say something?
Sir, it will be A square. We will substitute the value of B square. Then it will be A square plus AC upon AC plus C square.
Excellent. Very good. And
Sir, then we will take A and C common. Then it will be A plus C upon A plus C.
So, I mean, you are not speaking correctly, but I can understand your intentions are perfectly correct. But your spell is a little problem. But I know you are saying it correctly. What you mean to say is, you want to say that I substitute this B square as AC and this B square also as AC. So, till here you were vocally very correct, and you also said it correctly that then I can take A common in the numerator, it becomes A plus C, AC, A plus C, okay? That is where the problem is. And you can in the denominator take C common. So still inside the bracket you are left with A plus C. And because A plus C is common in the numerator as well as denominator, so you can cancel it out. And you are left with, see, I am writing it below this, but I don't have a place below this, so I am writing it here. You get equal to A over C. Oh my god, but this is your LHS. So that is nothing but your LHS. So if I proceed it here, see, if I proceed it below, I come here and I get A over C, that is equal to, and therefore that is equal to LHS. So my obvious steps to end this question will be, as LHS is equal to RHS, therefore A over C is equal to A square plus B square over B square plus C square, or A comma C comma A square plus B square and B square plus C square are proportional. You have to give it a dream end. This is the dream end what a teacher or examiner expects a child to end this question into. Okay? Is that clear to everyone? Hope you understand this. Your question number 13 from exercise 7.2, which is if B is the mean proportion between A and C, again that means B square is equal to AC, because this is given, because it is given that B is the mean proportion between A and C, that means B square is equal to AC. You need to prove what we need to prove. We need to prove that AB plus BC is the same, that is the mean proportion. That means square of this is equal to A square plus B square and B square plus C square, meaning need to prove that AB plus BC is the mean proportion of A square plus B square and B square plus C square. So if AB plus BC needs to be the mean proportion between A square plus B square and B square plus C square, that requires the proving that AB plus BC square is equal to A square plus B square into B square plus C square, isn't it? तो अगर हमको ये प्रूव करना है कि भैया AB प्लस BC मीन प्रोपोर्शन है बिटवीन A स्क्वायर प्लस B स्क्वायर एंड B स्क्वायर प्लस C स्क्वायर, इसका मतलब यही तो हुआ कि इसका स्क्वायर मस्ट बी इक्वल टू दिस इनटू दिस. जैसे कि B वाज द मीन प्रोपोर्शन बिटवीन A एंड C, सो B स्क्वायर वाज इक्वल टू AC. तो ये गिवन है और हमें ये टू प्रूव करना है. तो क्या क्वेश्चन में क्या करना है समझ में आ रहा है?
यस सर.
तो कैसे करना है? अब दोनों ही साइड कॉम्प्लिकेटेड है, तो ऐसा करते हैं कि क्यों ना हम इसमें RHS का स्कोप खोलने का ज़्यादा है, मुझे ऐसा लग रहा है, क्योंकि B स्क्वायर इज इक्वल टू AC पुट करा था पिछली दफ़ा, इस दफ़ा भी कर सकते, तो क्यों ना हम RHS पकड़ लें, कैच होल्ड ऑफ RHS, एंड इन दैट कैचिंग होल्ड कीप इन माइंड दैट यू नीड टू सब्स्टिट्यूट इन प्लेस ऑफ B स्क्वायर AC. तो क्या मिलेगा तुमको? देखो A स्क्वायर प्लस AC और AC प्लस C स्क्वायर, और जैसा कि पिछली दफ़ा हमने इसमें A कॉमन ले लिया था, तो A प्लस C, एंड हियर आई हैव टेकन C कॉमन, तो A प्लस C आ गया था. तो सी व्हाट आई एम एक्चुअली लेफ्ट विद इज A इंटू C कॉमन आउटसाइड द टू ब्रैकेट्स, एंड दोज टू ब्रैकेट्स आर A plus C and A plus C. That is, you can see
It can be written as
A plus
B
C whole
square
square.
bracket A plus C whole square.
isn't it? I mean A plus C whole square, A plus C to A plus C is A plus C whole square, isn't it?
Sir, we can write AC as B square again,
Yes.
and
Now,
then we can underroot it.
no underrooting is required. See, I mean your question, you're through better. See, AC can be written as B square. So B square into A plus C square is actually M square into N square, can be written as Mn whole square, isn't it? So you can write this as B into AC, A plus C. B into A plus C is पूरे का square, and therefore that becomes what? AB plus BC का whole square, and that is what you were supposed to prove, AB plus BC का whole square. See, so we started with RHS and we went to LHS by way of proving it. What I have done is B square into A plus C whole square. Why A plus C whole square? Because A plus C into A plus C is A plus C whole square, and B square is written as B square. AC is written as B square. Now, using this concept of indices here, M square into N square is Mn whole square. Likewise, this B square into A plus C whole square is B into A plus C पूरे का whole square. So B goes inside and multiplies, and this is what you were supposed to prove as LHS. So again, your formality, and that is the dream ending of the solution, is
Sir, I have done it in a different way.
very good. Congratulations. I'll just see by screen sharing, but let me finish off. Give it a dream ending. That is, as LHS is equal to RHS, therefore AB plus BC whole square is equal to A square B plus B square into B square plus C square, and that means, or AB plus BC is the mean proportion between, it will take some ink out of your pen, but you need to do this for the dream ending, and B square plus C square. See, as a teacher, if I can write, so as a student, you're supposed to write to give it a dream ending to the solution. I hope you understand this and the solution was quite clear to you. 2 का फोर्थ वाला पार्ट पब्लिक डिमांड पे है. इसमें ये आपसे कह रहा है कि ए बी एंड सी आर इन कंटिन्यूड प्रोपोर्शन. तो गिवन क्या है? गिवन है ए बी सी इन कंटिन्यूड प्रोपोर्शन. इसका मतलब ए अपॉन बी इज इक्वल टू बी अपॉन सी. ये गिवन है. इससे हम क्या समझें? इससे हम ये भी समझ सकते हैं कि बी स्क्वायर इज इक्वल टू ए सी, इजंट इट? बिकॉज ए बी सी आर इन कंटिन्यूड प्रोपोर्शन. और आप मुझसे कह रहे हैं फोर्थ पार्ट हमें प्रूव करना है. वी नीड टू प्रूव दैट ए स्क्वायर बी स्क्वायर सी स्क्वायर इन द ब्रैकेट ए की पावर -4 प्लस बी की पावर -4 प्लस सी की पावर -4 इज इक्वल टू बी की पावर -2 इन द ब्रैकेट ए की पावर 4 प्लस बी की पावर 4 प्लस सी की पावर 4. एक खतरनाक सवाल जो बोर्ड में आने के चांसेस आईसीएसई में कम है, सीबीएसई में इसके चांसेस थोड़े और ज़्यादा हैं, और यूपी बोर्ड के लिए अच्छा सवाल है ये. तो हम इसमें क्या करें भाई? देखो हमारे पास ये एक बचाव का रास्ता दिया हुआ है, और क्योंकि ये प्रूव करना है दोनों ही साइड कॉम्प्लिकेटेड है, तो हम एलएचएस को पकड़ लेते हैं. तो एलएचएस हमसे क्या कहता है? ये है ए स्क्वायर बी स्क्वायर सी स्क्वायर इन द ब्रैकेट ए की पावर -4 को हम क्या लिख सकते हैं? 1 अपॉन ए की पावर 4.
1 upon a to the power 4.
बी की पावर 4 को क्या लिख सकते हैं? बी की पावर 1 अपॉन बी की पावर 4. और इसी तरीके से सी वाले को भी लिख सकते हैं 1 अपॉन सी की पावर 4. तो देखिए हमने एलएचएस पकड़ा और उसको थोड़ा सुधार लिया. नाउ आई कैनॉट डू मच अबाउट इट बट देन टू पुट ए सी इन प्लेस ऑफ बी स्क्वायर हियर एंड हियर. I can put b square as ac. So therefore I get LHS as a square c ac or c square. While in the meantime I can substitute it here also, that is 1 upon a की power 4 plus 1 upon a की power 4 c की power 4, because a की power 2 and c की power 2. बिकॉज बी स्क्वायर ए सी है, तो बी स्क्वायर ए सी है, तो बी स्क्वायर का स्क्वायर बी की पावर 4 हो गया ए सी का स्क्वायर, यानी ए स्क्वायर सी स्क्वायर. ये बात समझ में आ रही है? अपॉन 1 अपॉन सी की पावर 4. तो देखो अंदर ये हो गया. अब बाहर तो ये ए स्क्वायर इंटू ए हो गया ए क्यूब. इसी तरह से सी इंटू सी स्क्वायर हो गया सी क्यूब. जबकि अंदर हम क्या कर सकते हैं? एलसीएम ले सकते हैं. देखो a की पावर 4 ए स्क्वायर सी स्क्वायर और सी की पावर 4 का एलसीएम क्या आ सकता है? a की पावर 4 c की पावर 4. देखो a की पावर 4 गोज इन दिस c की पावर 4 टाइम्स. इसी तरह से a स्क्वायर सी स्क्वायर कैन ऑल्सो गो इन दिस हाउ मेनी टाइम्स? a स्क्वायर सी स्क्वायर टाइम्स, इजंट इट?
प्लस a4.
और यहां पर c की पावर 4 गोज इन दिस a की पावर 4 टाइम्स. दिख रहा है? अब तुम देखो इसमें ये क्या हो गया? ये हो गया देखो, अगर हम ये a की पावर 4 c की पावर 4 यहाँ बाहर निकाल लें तो ये बहुत खुश हो जाएगा. बाहर जो पड़ा हुआ है उनको कंपनी मिल जाएगी. यहाँ a क्यूब c क्यूब पड़ा हुआ है और उसको नीचे a की पावर 4 c की पावर 4 मिल जाएगा. वो खुश हो जाएगा, कह रहे वाह मेरे जैसा आ गया. और जबकि यहाँ अंदर हम क्या कर सकते हैं? c की पावर 4 बेचारा फ्री हो जाएगा डिनोमिनेटर से. ये देखो ए स्क्वायर सी स्क्वायर को हम ए सी लिख सकते हैं ना, ए सी का स्क्वायर और प्लस ए की पावर 4 ऐसे कर लेते हैं. तो तुम ये देखो कि एक म्यान में दो तलवारें नहीं रह सकती ना. तो न्यूमरेटर डिनोमिनेटर में ए क्यूब कट गया, सी क्यूब कट गया, तो बचा क्या? 1 अपॉन ए सी. और अब तुम्हारे दिमाग की बत्ती जली जा करके कि अरे यार ये ए सी जो है ये तो बी स्क्वायर के बराबर है. ओ यस, ये ए सी तो बी स्क्वायर के बराबर है, यानी कि 1 अपॉन बी स्क्वायर पुट कर दो, है ना? ए सी तो बी स्क्वायर के बराबर है. सी की पावर 4 देखो, ए सी तो बी स्क्वायर के बराबर है, तो बी स्क्वायर का स्क्वायर बी की पावर 4. अरे वाह यार, ये तो आ गया. शाबाश, तुम लोग तो बहुत तेज हो यार. तुम लोग तो उसको आराम से देखो 1 मिनट के अंदर कर लिया. अब इसके बाद इसके नीचे जो स्टेप है वो नीचे तो मैं जा नहीं पा रहा हूँ, तो मैं देखो यहाँ पर थोड़ा सा आ रहा हूँ. तो 1 अपॉन बी की पावर 2 को लिख सकते हैं बी की पावर -2. और c की पावर 4 प्लस b की पावर 4 प्लस a की पावर 4। अरे पर यही तो हमें प्रूफ करना था, इक्वल टू RHS। फिर आप इसके नीचे आंसर डालेंगे एज LHS इज इक्वल टू RHS, हेंस प्रूव्ड। इतना अगर आपने लास्ट में 2 लाइन ये इक्वल टू RHS या उसके बाद नीचे एज LHS इज इक्वल टू RHS नहीं लिखा, तो भिन्न भिन्न प्रकार के बोर्डों में भिन्न भिन्न मार्किंग स्कीम होती है। ICSE में इसका 1 नंबर कट सकता है। ओके,
Yes.
नंबर 23 फ्रॉम योर रीसेंट एडिशन बुक, क्वेश्चन नंबर 23, थर्ड एंड फिफ्थ पार्ट फ्रॉम एक्सरसाइज इज
That's 7.2.
7.2 of ML Aggarwal class 10. It's given that ABCD are in continued proportion. Now because ABCD are in continued proportion, that means very clearly that A over B is equal to B over C is equal to C over D, and let us say this is equal to K. So if the font appears to be small, you can just zoom your screen so that you can see it more clearly. So this will this assumption K will enable us to take A is equal to BK, B is equal to BK, that is equal to CK square, that is equal to DK cube. The other day I told you all this. A will be equal to BK, but B is equal to CK, isn't it? B is equal to CK. So instead of B I put CK, so it becomes CK square. Then C is equal to DK, so in place of C I put DK, so DK into K square is DK cube. So that already emphasized previously with you. So A is equal to DK cube. Likewise B is equal to CK square, isn't it? B is equal to CK and C is equal to DK, so B is equal to CK square, and likewise sorry B is equal to DK square, I am so sorry. See, B is equal to CK, B is equal to CK, and C is equal to DK, so B is equal to DK square, and likewise C is equal to DK. So I will be using this information to substitute in place of A DK cube, in place of B DK square, and in place of C DK. So if I am doing third part, I mean this is a general information which I have derived, and now I am doing the parts for you. So say I am doing the third part first for you. So in the third part, I catch hold of LHS. The LHS is A plus D into B plus C minus A plus C into B plus D. So in place of all A, B and C's, I will put BKs, CKs, DKs, and I mean all D in terms of D's. So in place of A, I am putting DK cube. So DK cube plus D. Likewise, this is multiplied with B plus C. So B is DK square plus DK. Likewise, minus A plus C. A plus C is what? A is DK cube plus C is what? DK. And likewise B is what? DK square plus D. So if now I take D common, I am left with D common from in this bracket also and D common from this bracket also. So I get D square in the bracket K cube plus 1 into K square plus 1. While if I take D common from this bracket and D common from this bracket, in fact I can take one K common also here, you can see. Not only that, I could take D common from here,
Yes, sir.
I could have taken D common and one K also common here. So actually I can take one K also common here, so I am left with K plus 1. Likewise I can take D and K both common from this bracket, D and K both common, and one D common from here. So D square K I can take common, and inside I am left with K square plus 1 into K square plus 1. I hope you follow. And
Yes, sir.
now if I can take KD square common from these both the terms, and hope I have not gone out of focus, that I get k cube plus 1 into k plus 1. That means this bracket is multiplied with this bracket. So I get k power 4 plus k cube plus k plus 1, opening this bracket. And while a minus sign asked me to put a bracket, so I put a bracket C. I multiplied this bracket with this bracket. K cube into k is k to the power 4, k cube into 1 is k cube, 1 into k is k, and 1 into 1 is 1. Minus this t square k has come out, and now I am opening this bracket. I get inside the bracket k to the power 4 plus 2k square plus 1. So that will cost me one more step. So I'll just give you some space, some breathing space here, so that I can write it, that k d square, it becomes now what? K to the power 4 plus k cube plus k plus 1 minus k to the power 4 minus 2k square and minus 1, isn't it? So still I want more breathing now. See, I want more breathing. So k to the power 4 and k to the power 4 cancels off. You can see 1 and 1 cancels off. So I am left with k d square inside the bracket, k cube, which is there still, then minus 2k square, which is still there, and in fact this plus k, which is still there. The rest k to the power 4 and k to the power 4 goes off, and 1 goes off. I can take 1k common, I can see. If I take 1k common, I am left with k square d square, and here it is k square minus 2k plus 1, isn't it? I can also think this as k square d square and k minus 1 whole square, isn't it? Isn't it? See, k minus 1 whole square is k square minus 2k plus 1, and therefore I can also think this as k d k minus 1, this entire ka whole square, isn't it? But now if I take you here, what do I get? It becomes actually k square d minus kd. I am becoming more frank with it. Kd into k minus 1, I open it, k square d and minus kd, and k square d, I remember k square d is nothing but b, while kd was nothing but c whole square, and that is what I was supposed to prove. See, that is equal to your RHS, and proved the third part. Did you follow this?
Yes, sir.
Okay.